Welcome back to the channel, everyone. Today, we're stepping into the mind-bending world of quantum computing. This is not just science fiction, it's a revolutionary technology that could change how we solve the most complex problems in the world. So, let's decode the quantum mystery together. Quantum computing is a type of computing that takes advantage of the quantum states of subatomic particles to store information. Unlike classical computers, which use bits as the smallest unit of data, quantum computers use quantum bits, or qubits. These qubits can represent and store information in both zeros and ones simultaneously thanks to a principle called superposition. To understand quantum computing, we need a brief overview of quantum mechanics. Quantum mechanics is the science of the very small. It's the rules that govern the behavior of tiny particles like photons, electrons, and quarks. In the quantum realm, particles can be in multiple states at once, as I mentioned with superposition, and they can be entangled with each other across distances. Quantum computers encode information into qubits and then use quantum phenomena such as entanglement and superposition to perform calculations. This allows them to process vast amounts of data much faster than the best supercomputers today. Imagine solving problems that would take current supercomputers millions of years to solve, and quantum computers could potentially do it in just a few minutes. One of the most famous quantum algorithms is Shor's algorithm, which can theoretically break much of the encryption that keeps the internet secure. Another is Grover's algorithm, which could search databases in a fraction of the time it would take a traditional computer. These algorithms show just how transformative quantum computing could be. Quantum computing could revolutionize numerous fields. In medicine, it could speed up the analysis of genetic data and improve personalized medicine. In finance, it could optimize asset management and automate complex transactions. And in cybersecurity, quantum technology offers the potential for virtually unbreakable encryption. Despite its potential, quantum computing faces significant challenges. Qubits are incredibly sensitive to their environment, and keeping them stable, known as quantum coherence, is a major technological hurdle. Plus, quantum computers require extremely cold temperatures to operate, colder than the depths of outer space. That's just a glimpse into the world of quantum computing. It's an area of technology that might seem intimidating, but its potential to change our world is incredible. If you're fascinated by what you've learned today, like this video, subscribe to our channel, and hit the bell icon to stay updated on all things futuristic. Thanks for watching, and I'll see you in the next one.